momentum and energy of the recoiled hydrogen atom. So we will talk about this topic. We know that when there is a transition of electron from higher energy orbit to lower energy orbit, the photon is emitted, and as a result the hydrogen atom is recoiled in the backward direction. So we have to find that what will be the momentum and the energy of the recoiled atom. This I am taking that, suppose this is the energy state N1 and N2. This is the emission of photon. So now here what we have, that this is the atom. This is the atom. When there is a transition of emission of photon, this atom is recoiled in this direction. So this is the atom, this is the recoil, this is the momentum and energy of this recoiled atom. Recoiling of atom. When transition of electron takes place from higher energy state to lower energy state, a photon is emitted and atom is recoiled in opposite direction, opposite direction of photon. So photon is emitted in this direction, then atom will be recoiled towards the left side. According to law of conservation of momentum, since there are the two particles, one is the photon and second the atom. So definitely when in this process the momentum is always conserved. It means that the momentum of the photon and the momentum of the atom will be equal but opposite in direction. So momentum of recoiled atom equal to momentum of photon so this P equal to h upon lambda. Lambda is the wavelength of the photon, h the Planck constant, where h Planck's constant and lambda, this is not de Broglie wavelength. De Broglie wavelength. And now we know that the energy E equal to h. This is the energy of the photon. Nu is the frequency. So this is now h c upon lambda. C the speed of light. So this is equal to so much. So now this 1 upon lambda. Therefore 1 upon lambda equal to, this is equal to E upon hc. E upon hc. So now we have here, therefore P equal to h into E upon hc. This will cancel. So this P equal to E upon c. This is the momentum of the atom. See the speed of light. C. Speed of light. Now this E, because this transition is being taking place from N2 to N1. So this E will be given here. Now we are talking only about the hydrogen atom. E is equal to minus 13.6 upon N square electron volt. So now this E is equal to what? This is in En, the nth energy level. Nth energy level. So now we are talking about this E, then we will have to find the difference of these energies. So this E is equal to En2 minus En1. So if we calculate, then this is now 13.6 into 1 upon N1 square minus 1 upon N2 square, so much electron volt. Electron volt. This is now energy E. So now then we can have this momentum P. Momentum P equal to 1 upon C into 13.6. So we better can write to this one 13.6 upon C into 1 upon N1 square minus 1 upon N2 square, so much. Now this will be in kilogram meter per second. Kilogram meter per second. So this we can find the momentum of the recoiled atom with this formula, that if we know this value of N1 and N2 and C is known to us, then we can calculate it easily. So this is the formula for calculation of momentum. Now energy of the recoiled electron, recoiled atom, energy of recoiled atom. E equal to P square upon 2m. M is the mass of hydrogen atom. M equal to mass of hydrogen atom. Now P we know to this one, this is not so, E upon C. So this E is equal to 1 upon 2m into E upon C whole square. This is the value of P that we have here. So now this we can write E equal to this so just we square to this one, then we will find. So this is what the kinetic energy of the kinetic energy of the recoiled atom. So this is equal to 1 E square upon 2m C square. This is the kinetic energy. And then you can put the value of E from here, so much. And if you put the value of, or you put the value of this P, then you can find the momentum of this kinetic energy of the recoiled atom. So we can also write it to be like this one, that this kinetic energy is equal to 1 upon 2m P square. So in place of P to this one, this we are having 13.6 upon C into 1 upon n1 square minus 1 upon n2 square. Now so much, this is now whole square. This so much will be the electron volt. This is in electron volt. So this will give you the kinetic energy of the recoiled atom. So when the photon is emitted, then the atom is recoiled in the backward direction. So that will have the kinetic energy. So this we have calculated the kinetic energy of the recoiled atom. So this will give you the momentum, and this will give you the kinetic energy of the recoiled atom. So thank you very much.